In this video, I will show you how to use TVM Solver to solve amortization and annuity problems. First of all, we will go to this app. The first one, Finance, enter. TVM Solver, enter. So you could see these symbols for TVM Solver. Now let's talk about the variables in the TVM Solver. This N stands for number of compounding periods. I% means annual interest rate as a percent. PV stands for principal or present value. PV is a positive if you receive money. PV is a negative if you take the money out of your pocket. PMT stands for amount of each regular payment. If it is a monthly repayment for a loan, it is always rounded up. Otherwise, you cannot pay off the loan on time. If it's a monthly withdrawal from an annuity account, it's always rounded down. Otherwise, you will withdraw more money than the desired amount. PMT is a positive if you receive money. PMT is a negative if you take the money out of your pocket. FV stands for future value, or a value of the investment at maturity. FV is a positive if you receive money. FV is a negative if you take the money out of your pocket. PV stands for number of payments per year. CY stands for number of compounding periods per year. Normally, these two are equal to each other. For the answer about financial problems in IB exam, it's always 2 decimal places. If there's no special requirement, like $123.45 as a solution. Before we get started, let's talk about some definition of finance terms. Amortization is the process of repaying a loan with a series of regular repayments. PA means by the year or each year. Interest paid equals total repayment minus amount borrowed. Outstanding balance is the amount still to repay. Lump sum is an amount of money that is paid at one time. Annuity is an investment where an individual makes a lump sum deposit and then makes a regular withdrawal over a fixed time period. The investment earns interest according to the balance of annuity each time period. Let's go to guided practice 1. Amy finds an annuity that counts for monthly compounding and monthly payments. The annuity pays 5.6% annual interest, compounded monthly. Use the TVM calculator to determine the monthly payments Amy needs to make over 50 years to have $1 million at the time of her retirement. For this N, basically means number of compounding periods. It will be 12 times 50. Compounded monthly, which means each year it will be compounded 12 times. For 50 years will be 12 times 50. I%, that's annual interest, will be 5.6. Present value, you will put the 0 because you don't know. Whenever you don't know the number, you will put the 0. PMT, we are looking for, so still put the 0. For the future value, it will be positive $1 million because this is the money you will receive in the future. Therefore, this will be positive. For payment each year, it will be 12 times. For compounding period each year, it's still 12 times because it says monthly here. Now, I already put this number into the graphing calculator, TVM Solver. Then you need to go to here, PMT, we are looking for. So how many dollars you need to put into this annuity account each month? You will use this alpha enter to solve. Since this is the money you took it out of your pocket, that's why you got a negative. So it will be $304.26. Let's go to guided practice 2. Tony wants to have $100,000 in 35 years in an account that earns 6.25% compounded quarterly. How much money should Tony need to invest now to achieve the goal? As we know, compounded quarterly means compounded 4 times a year. Therefore, we have this N equals 4 times 35. The interest rate is 6.25%. Present value we are looking for, therefore we will put the 0. PMT we don't know, so put the 0. Future value, that will be $100,000. This is the money you will receive. Therefore, this is a positive. For P by Y and C by Y, both is 4 because it's compounded quarterly. Now, I will put into this TVM solver. For this N will be 4 times 35. Percentage will be 6.25. PV, that's the value we are looking for, so we put the 0 first. PMT will be 0. Future value will be 100,000. Since compounded quarterly, therefore, here's a 4. This is a 4. Then we move back to this PV, present value. We do alpha, enter. We got this number. That will be $11,411.07.